Dear children, now we'll study superposition principle. Here we'll study superposition of electric force. You remember, superposition means addition. Simply, superposition means addition. If a quantity is scalar quantity, then algebraic addition. If a quantity is vector quantity, then vector addition. Here we will study superposition of electric force. Means it is the vector addition of electric forces. What do you mean by it? You know, if there are two charges, then there will be electric force between them. For a multiple charge distribution, if there are more than two charges, suppose you take one example, there are three charges you see here, Q1, Q2 and Q3. You remember, a charge cannot exert force upon itself. So, here we want to find what is the net force acting upon Q1. Here, there are two other charges, Q2 and Q3. Q2 exerts force upon Q1. Q3 also exerts force upon Q1. But Q1 itself cannot exert force upon itself. So, here you see, force acting upon Q1 due to Q2 is F12. Similarly, force acting upon Q1 due to Q3 is F13. So these are the two forces acting upon Q1, that is F12 and F13. So what is the net force acting upon Q1? Net force acting upon Q1, that is, let it be F1, that equal to F12 plus F13. It is your, you see, it is the vector addition. So superposition principle of electric force means it is for a multiple charge distribution, the electric force acting upon any charge is the vector sum of the forces upon the given charge due to all other remaining charges. That means if you have another charge here Q4, then another force you will get upon Q1, that is due to Q4, that will be F14. So net force will be F1 will be F12 plus F13 plus F14. It is your vector addition. We have to take here vector addition, not algebraic addition, because electric force is the vector quantity. Let us solve one question based upon this superposition principle. You take a equilateral triangle. Equilateral triangle. It is point A, it is point B, it is point C. Suppose there are three charges, each of small q at the 3 points A, B, C of the triangle. You take each side equal to A. Now here question is asked to find the net force acting upon any charge. Here I want to find the net force acting upon the charge Q at A. Here you see another two charges Q each at B and C respectively. So here you find what is the force acting upon this charge due to this charge. Let it be F1. As here they are of same nature, so the force is repulsive. So Q, this Q repels this Q. So direction of F1 is this is the direction of F1. Similarly, force acting upon this charge due to this charge. As they are of same nature, the force will be repulsive. It is your F2. Now what is the net force acting upon the charge at A? So what is F1? F1 is force acting upon this charge due to this charge. That is small k. You know force is Coulomb's force is k q1 q2 by r square. That means this q into this q. That is q square divided by a square. Similarly, you find F2. F2 means force acting upon this charge due to this charge. That is small k q square by a square. What is the angle between them? As it is equilateral triangle, this angle is 60 degree. All the angles are 60 degree. You know for equilateral triangle. So as it is 60, it will be 60 because it is opposite angle, vertical opposite angle. So what will be the resultant force? Resultant force, here you have to apply law of vector addition. So you know if there are two vectors A and B, if theta is the angle between them, then the resultant will be F net will be F1 square plus F2 square plus 2 F1 F2 cos here angle is 60 degree. So here you see F1 magnitude is F2 magnitude. In place of F2, you can write F1. That means F1 square plus F1 square plus 2 F1 square, because F2 is F1 here, cos 60 is your 1 by 2. That equal to root 3 F1. That means root 3 k q square by a square. It is your magnitude. Now what is the direction? For direction, you can apply beta is equal to tan inverse here F2 sin theta by F1 plus F2 cos theta, where this beta is the angle made by the resultant force with F1. So here another concept you know, if F1 and F2 are of same magnitude, then the resultant force will divide the angle into two equal parts. That means here you see F1 magnitude is F2 magnitude, so the resultant force acts in a direction which divides the total angle into two equal parts, means it is 30 degree. It is your direction of F net. It is all about your superposition principle.